Let's talk about osmosis and tonicity. Osmosis is the diffusion of water across a semi-permeable membrane. But what is diffusion? Well, diffusion is the net movement of a solute from a high concentration to a low concentration. First, we should know that a solute is a dissolved substance, something like sodium chloride. And a solvent is the thing that the solute is dissolved in. In our case, we're going to be talking about water. A solution then is the result of the solvent and the solute together. So that's what we have here. We're dropping some red dye into a container, and initially there's going to be a high concentration of that red dye in the area where the drop lands. But we're going to move from our high concentration towards a low concentration and spread out, ultimately adding more and more of that to the areas where there was none until it's equally spread out. There's no area of high concentration, no area of low concentration. So what does that have to do with osmosis? Well, in osmosis, the solute, the dissolved substance, can't move. So the solvent does. That's going to be water in our case. We can see that we have a semi-permeable membrane down at the bottom of this. And that membrane is permeable to water. Water can go through it, but our dissolved substance can't. There's a lot of dissolved substance on one side, and there really isn't any on the other. So how do we make these equal if the substance can't move to the side that doesn't have any? Well, the answer is the water is going to move. So we're going to get water moving from the side that has less dissolved substance, meaning that it has more water, over to the side that has all of that dissolved substance. Now this can actually even create some pressure, so that over time what's going to happen here is we're going to see changes in the water level. Water is going to get higher on one side and lower on the other as water moves to the side with all of that dissolved substance. When we're talking about tonicity, we're talking about a relative concentration of a solution in two different locations. So in this case, as we can see over to the right, we have a cell placed in an environment. In this case, it's just a beaker. And there are three different scenarios we could potentially have. One, what we call isotonic, where iso means the same. It means we have the same concentration of solute in both the cell and in the surrounding environment. Water is going to move into the cell, but water will move out of the cell at the same amount. So we can say that this has no net movement. And that means that the cell is going to stay the same. Now, in the case of a hypotonic environment, where hypo means below, we're going to have an environment that is very watery compared to the cell. That is, the cell has more solutes inside of it. So water will move from the more watery area to the less watery area. Water is going to move into the cell. Now, the thing about molecular movement, it's always going in every direction, but we're going to have less water moving out of the cell than we have moving into it. So what this means is we're going to have water moving into the cell, and the cell is going to grow. We might say it's going to swell, and it could potentially burst. So what about hypertonic? Well, hyper is going to mean above or more. And so we can see here that the environment has more solutes, more dissolved substances than the cell does. That means that the cell is going to have more water. And we're going to expect water to move out. Now, as before, water is going to move in, but much less so than water will move out. And what that means is that water moves primarily out of the cell, and we're going to expect the cell to shrink as a result of that. So that's osmosis and tonicity.